Hi everyone, this is Michael and from Velociraptor, and today I just wanted to give everyone a quick rundown on our new tool, Velociraptor, and just showing off some of the latest release. So I just want to go through the installation and show everyone how to deploy Velociraptor. So here I have the latest release, 0.2.3. Have two binaries. The ELF one is the Linux binary, and the executable is the Windows binary. And what we're going to do today is we're going to deploy the Velociraptor server and client, and we're going to see how we can install it on Windows and have a bit of a play around the UI and see what it's like to run it. So the first thing that we need to do is to build to create ourselves a server configuration, and it's very easy to do that. We will just run the binary. Everything is the same binary. There we go. It's the same binary, and it basically does everything in the same tool. And so the first thing that we need to do is create a new configuration, and that basically creates new keys. So we can just config generate, and this will basically create our own unique configuration with new keys. So we just created and redirected to a file, and it's expected that we would edit it a little bit. And so you can see that it generated new keys for us, new CA keys, new service certificates, etc. We'll just drop the poll frequency. The most important thing to set up when you change when you create a certificate, a new configuration, is to tell it where to connect, which are the server URLs. Velociraptor.velocitex.com. So in this case, we're just going to serve it on a public DNS, and so we can change our endpoint here. The other interesting thing is where to store the configuration when we install it. And on Windows, it will be installed in program files by default. And finally, on the server, where to store the files that we are actually downloading from the client, and where to store the database. So we're going to just put it in the temp directory for now, so that we could have a look at it later. But you can see that basically most of the other things are already filled up. You can see that there is a private key generated, certificate and the bind ports and everything like that. So this is really all we have to do. Just look over the configuration, make sure it's okay. What we want to do next is, so this is the server configuration. We want to generate a client configuration, and the client configuration is generated from the server configuration, but it's basically just the client part. So it removes all the secrets and things that are needed for the server and just keeps the things that are needed for the client. So config client. So if we have a look at it, see it's basically based on the server configuration, but it just has minimal stuff in it that just the client needs. So it needs to know where to install itself and all these kind of things. And it doesn't really have any secrets. It just has the CA certificate here. So we're going to just redirect it to my client config.com. Yeah. And so now, if we have a look, we have two kinds of configurations. We have the client configuration and the server configuration. So the easiest way to deploy the client is to embed the client configuration in the server, in the binary itself. So let's see how to do that. So before we continue, if we specify the configuration on the server, then we don't have to keep putting in the -- config flag the environment variable, if you know. Okay, so if we have a look at the different kind of options, we can have config repack, which basically packs the config into the binary, and config repack -h. It tells us that we could use these flags. So the executable that we're going to use is we're going to repack it into the Windows binary, and it's going to be the client configuration, and we're going to call it myvelociraptor.exe. So this command basically copies the distributed binary, copies the configuration into that, and creates a new binary that has an embedded configuration already in it, so it knows how to talk to the servers, and you don't have to worry about config files and so on. It's just that binary, and it has everything in it. So we're going to move this binary into a virtual machine. And now we should be able to access it from our Windows machine. So let's take a look. Okay, so it's the same binary. This is the Windows executable. But this one has the config already embedded. So let's have a look. Config shows the config. And we can see that it already knows that will be the endpoint, and it's going to install itself into program files. Okay, so that's all the configuration we really need to do. So what we need to do now is simply just create a user account and run the UI. So let's have a look. The UI requires logging in from a user, so we just need to add a user add, and we just fire up the front end. And you can see that the front end is ready to handle client requests. At 8,000, the front end is where the clients connect to, and the GUI is ready to handle it at 8,889. So now it's asking us for the user account that we created before, so we can just log in, and there we have it. It's up and running. But there's no data in it yet. We haven't really done anything. It doesn't have any clients it knows about, but it's up and running. So now what we want to do is just test that we can connect the client and the server, and all the configuration is more or less correct. So we could just use our special packed version of Velociraptor and just run a client. And you can see that the first thing that it does is it starts up, creates a crypto key, and it connects to the endpoint. And then once it connected it to the endpoint, it enrolls. So enrolling means that it basically says to the server, I'm a new client, you don't know about me, but here I am, and this is my public key, and then it starts to talk to the server. And the server then issues some VQL statements to ask the client about itself. So you can see that there is this interrogation going on, and there's some VQL that goes on, and the server is basically asking the client certain things. And once that's done, the client replies to the server, and then it basically sits and blocks on a reader. So unlike Gur, Velociraptor doesn't really poll. It just sits there and waits for messages from the server. So if we go over here and then we search, because we only have one client, we can just search for all of them. So that's the only client that's there. You can see some information about it, OS version, host, etc. And if we have a look at it, you can see that the VQL drill down shows us the responses from those VQL statements that were issued when it was already involved. So we can see, we know about this machine now, and we can do various things about it. So let's have a look, first of all, at the virtual file system. The virtual file system is the server's view of what the files on the client are. And it has some files and registry. It kind of puts it all in the same view. And at the moment, the server doesn't know anything about the client, so it doesn't have any data. So if we click on this button that will refresh the directory, then we can see that the client will basically do a directory listing of this directory and tell us what files are in there. So here's the C file, a C drive, and so on. So over here we have the users. So it just shows us these directories is empty. There's no data available, so we can refresh the toolbar. But typically, when we look at the users' home directories, that's probably the most interesting part in many installations. And so we can do this recursive directory listing just to save some time instead of having to click. And what that will do is it will actually recurse through this directory and list every single directory under that to a depth of 5. So that makes it a bit quicker for us to search, and we don't have to constantly go to the client and look for things. So you see, it's pretty quick. It does search, fairly deeply into it, and we can see these are all the directories, files, etc. that we can see there. So you can see that here we have some binaries, and you can see the MAC times here, the size, the mode, and the name of the binary. But these are just metadata that we collected about these files, so it doesn't have the actual content of the file. So if we just try to do the text view and hex view, there's no content to show. So suppose that we wanted to see the actual data here, then we can click collect from the client. And then what I will do is it will bring the file in from the client. And you can see that immediately it shows the download icon here. And that basically tells us in this view that we actually have this file. We've collected the data for it. So now, if we click text view or hex view, we can see the contents of the file. And so, you can interactively kind of look through there and collect, whatever files you need. Maybe this file. And as you do that, it basically puts the icon there. And we can basically look through all these different things. Now, if we have a look at the flows, click on Manage Launch Flows. So the concept of flows is basically a flow is an interaction with the client. So whenever we ask the client to do something, that's a flow. So you can see that as I was clicking through the VFS before, it issued different flows to the client and fetched different files, and each of those was its own flow. And so, it tells you which is the creator of the flow and when it was created, etc. And you can see that over here, what kind of flow it was. The VFS list directory, for example, of the different directories. And this was a recursion depth of 5. So each flow has it has logs, so it tells us what it's done, and possibly results. So VFS doesn't really have results. This one does. downloaded some files, and it has the results here. Okay, so these are just interactive kind of flows, but let's look at some of the more interesting things that we can do. You can go to the artifact collector, and we know it's a Windows system, so we're only interested in Windows artifacts. And over here we have a bunch of different things, basically for forensic artifacts of Windows systems. And if we click on those, then we can see that essentially they're all just VQL statements that are going to be executed. So when we run this collection, we'll push the VQL statement to the server, to the client, and run that artifact on the client and collect the data and bring it back. So we can choose that. For example, this particular one lists all the user accounts. It uses a couple of ways to do it, but I think it's quite useful to list user accounts. So we'll select that one, and then we launch it. You can see that it basically just has some metadata and so on. If we go back to the launch flows, then we can see it's already finished. It's a pretty quick one, and you can see that it has results now, and the results are all the user accounts basically on the system. So we have the name, description, and so on, basically in a table form, and that result is controlled by the VQL that we put that is in the artifact definition. Okay, so this is kind of interesting. So it appears to be working, right? So the client is talking to the server, and you can see that because we can see the debugging output now. We can see that essentially what's happening here is that the client is waiting for the server to ask it to do something, and then the server sends a VQL request, and then the client does it and goes back to waiting. So it doesn't actually poll, and it basically is very quick in responding to the data. Okay, so this appears to be working. But what we would like to do now is to actually install it. So this was just running on a command line, but in reality we want it to run as a service, so we can actually have it running all the time, basically. And so it's very easy to do. You just service install. Okay, and then what we'll do is it copies the binary into the right place. This will set in the configuration file, and install the service and starts it. So now, if we have a look at the task manager, then we should be able to see it running as a service.
You've got mail.
There it is. And it's running as a service there. And if we look at the details, that shows us the process, and you can see that it's running as a process, running a system, and footprint is around 5 megs. So that will work about 20 megs, something like that, when it's in full operation. But it's pretty small. The memory footprint is quite small. So this is running as expected. Okay. So now I want to show another thing. So I have the server running here, and what I want to show is I want to run Velociraptor in scale. So I actually want to run it on 1,000 machines, but I don't actually have 1,000 machines on me. So we can see that there is a pool client. The pool client is basically a way of running the same client 1,000 times. So it looks to Velociraptor as different clients because they're all different keys and they use different IDs, but they're actually just running in the same process, just different threads. It's a good way of just running a lot of load on the server and just showing like how it behaves under a lot of load, so 1,000 clients. So what I'll do is I'll just Okay, so just export the config file, and then I can run client-h, and it's telling me, okay, there's this number and write back directory. So I'm going to run it on 1000. And that produces a lot of output. So I'm just going to redirect it somewhere. Okay, and you see that it basically starts to generate a bunch of keys, and it contacts the server. And what it's doing is it's creating new clients and essentially contacting the server, enrolling them all. So they're all basically enrolling as we speak. So it's going to take a little while, but while it's doing that. So now you can see that when we search it, then we can see all of these new clients coming up in a search box. And of course, they're all exactly the same. They have the same host name and everything, but they look different. So, we can still sort of use them and do all the usual things. They have the different interrogation details here, and they each have their own file system. So we can list the file system and so on. But these are Linux machines because we're running a Linux machine, the pool client. So you can see that as this is running, we may be able to collect some of the Linux artifacts, perhaps. Maybe this one, which tells us all the mounts, disk mounts. And we can see here that the disk mounts, all the different file systems and so forth. Right. So this is running, we've just run flows on single hosts, but that's not super interesting. What is more interesting is being able to run the flow on all the hosts at once. And in order to do that, we have what's called a hunt. So a hunt is basically the ability to run the same flow on lots of clients at the same time. So we can add a new hunt, and just like before, we could select the different flow to run, and generally we'd run an artifact collection or something like that. And we can run one, for example, on the Windows machine. For example, let's say disk info. Okay, and we can restrict, so we only run on Windows. Okay. And you can see that this is, now we're reviewing the hunt and making sure it's okay. So this client rate basically tells us how many clients per minute will be recruited. Okay. When we create the hunt, it runs in its paused state. So it basically doesn't run. We have to click start to actually start it. So we can start it. Okay. And you can see that pretty much as soon as we started it, it basically scheduled one. We only have one Windows system, so that's it. And so it basically just scheduled that one. So you can see here the scheduled. There's only one client with results, and let's have a look, and there it is, right? So we've collected some disk information from this one client. And we can see all the list of clients with results here, and so on. Okay. So that was kind of interesting, but let's try and do it on a Linux machine because we have 1,000 of those. So let's have a look here. Let's do this one, and we could go a little bit harder, maybe. And run it only on Linux. Yeah, that looks good. And let's run this hunt. Okay, so you can see that we are actually putting quite a bit of load on the system here with all the interrogation hunts running. But it's actually pretty quick. We've already, since I created it a few seconds ago, we've already scheduled 897 hosts. And we're almost done, right? So we've just basically run the artifact on almost 1,000 hosts in a few seconds. We're going to be almost finished now. You can see that the load just basically drops off now. We're pretty much done. Okay. So that's basically it. We can see the hunt, we can look at the results. Now, the last interesting thing that I wanted to show is that this is just a UI that just shows the files that are on the file system. So it's actually very simple. And that's why we don't really need to build very complicated export tools, because really it's all just very simple files. They're all individual files. So you can see that before we told it that it should store its files on this directory. So I just wanted to just quickly run through this directory to see what's there. And you can see that there's basically it's pretty self-explanatory. There's a big list of clients here. Each client has is a directory, and we have some information about each client, like its public key and last time we talked to it and so forth, and any flows that ran on it, and there is information metadata about these flows. And if the flow contains results, then we can see the results of each flow. And basically, so this is actually exactly the same as what you would see here. It's just in the file system. So all we had to do is simply let's have a look at the Windows machine, for instance. You can see that this is C9.1, and that's really the one that we've been looking at. C9. That's the file. This one. C916. This one. And you can see that this is the VFS that we've been looking through. And as we look through it, we can see all the metadata. So each of those contains the directory listing of that directory. And over here we can see the files that we've downloaded. These are the files that we downloaded. So this is basically exactly the same. Okay, so that's basically it. Hope this illustrates the tool, and please try it out and send some feedback and feature requests. Okay, thank you.